Cloud computing means different things to different people. The cloud in cloud computing is the hardware and software required to better utilize computing resources in multiple locations and to provide cost-effective and reliable computing on demand. China is quickly becoming a major hub for cloud computing development. Cloudsite Development, in partnership with TITA and HP Technical Services, is developing the first sustainable cloud computing data center in China. This development will be a 38,000 square meter data center project with Phase 1 scheduled to be completed by July 2012. Cloud sites are uniquely designed to accommodate enterprise and co-location users, consisting of a 4-story building with 3 independent data halls and a shared infrastructure floor, providing a compact, scalable, and highly flexible facility. The first floor is the shared infrastructure area with sufficient space to install 9 generators, which allows flexible load growth and up to N+2 redundancy. Medium voltage UPS systems provide continuous cooling power availability to meet uptime Tier 3 requirements for higher density configurations. Each upper floor contains a single cloud deck with its own UPS and cooling capacity. With build-out modularity and critical power options ranging from 2 to 2.8 megawatts, each cloud deck provides customers with flexibility for its space and power needs. With the universal focus on sustainability in data centers, KyotoCooling's self-regulated control system and overall operating efficiency are the foundation of Cloudsite's value proposition in the market. While KyotoCooling's innovative design is simple and elegant, it is the most advanced system currently available for data center cooling. The primary components of KyotoCooling is a rotating heat transfer wheel. This wheel uses simple passive conduction to transfer heat as air passes through the special corrugated aluminum of the wheel. Very efficient, high-volume, low-pressure fans are utilized to move air through the wheel. The inside air fans pull heated air from the ceiling plenum and move it through the heat transfer wheel, where the heat is absorbed. The cooled air is then delivered gently back into the data hall. The data hall is simply filled with air at the correct temperature for each server to draw on as required to meet its own cooling needs. The wheel then rotates the heated section into the outside airstream, where the heat is removed by cool air from the exterior. The outside air and inside air passes through the same wheel, but remain isolated by a center wall to keep them from mixing. If outside air temperatures are very high, the DX system begins to provide only the amount of additional cooling that is required. The KyotoCooling wheel continues to provide benefit even after the DX system begins to assist. The system rarely operates on DX cooling alone. Both inside and outside air is filtered to keep the data center clean. Cloudsite's dramatic building form clearly indicates how the building breathes to support the KyotoCooling system. Hot air is discharged from portals on the front face of the building, and cold air is pulled in through the sides of the building. The building form and function are fully integrated and visible. KyotoCooling provides far more responsive, efficient, and flexible critical cooling than traditional underfloor systems. It is the perfect solution for the dynamic server loading of cloud computing. Traditional systems must pressurize the plenum under the raised floor to force air to every area where a server might be installed. Perforated floor tiles must then be added to release air at each location where servers are installed. Air is drawn from the cold aisle by the servers. Heat from the servers is discharged into hot aisles, where some of it returns to air handlers for cooling, but some hot air always recirculates back over the top of the racks. This recirculation interferes with the cooling of servers in the top of the racks. KyotoCooling, on the other hand, simply fills the room with cool air at low pressure. The servers draw the cool air they need from the room and discharge it through chimneys to the return air plenum above. The room stays cool. KyotoCooling provides the precise amount of air required by the active servers. In traditional systems, perforated tile must be installed for both active and inactive servers. Fans must move pressurized air to all locations, wasting energy. KyotoCooling anticipates server heat load. Its control system measures the power going to the servers and knows when the server fans are ramping up and when the servers begin to generate heat. The KyotoCooling system supplies more cooling to the data hall proactively as it is needed. In traditional systems, the servers begin to generate heat, which warms up the return air. Recirculation of hot air increases. The system senses this increase and reacts by adding more cooling. KyotoCooling excels in the dynamic world of cloud computing by anticipating and staying a step ahead of the server heat load, whereas traditional systems simply react to heat-related problems after they develop. With the average PUE of enterprise data centers in China of approximately 2.1, Cloudsite facilities utilizing KyotoCooling produce extraordinary electricity savings over the life of the data center.